Okay, test is this Friday, so here we go. Again, I'm going to advise you to pause the video at any time, okay, to see if you can do it on your own and just check your answers. Number one, for each equation below, identify the slope and the y-intercept. The only way you can do that is if the equation's already in slope-intercept form. So it looks like they both are. In fact, if you want to write above it, okay, then you're good to go. So let's see, what's the slope for this line? It's 7 over 3, which means up 7, right 3. Okay, and the y-intercept is 0, negative 3. Here the slope is 1, and the y-intercept is 0, comma 10. Number 2, what is the slope of the graph on the right? Okay, so this one already has 2 points picked out for you. Hey, that's being really nice, right? So I'll start here, but you could start here. Okay, so I'm going to go down 2 and right 2. Okay, so which one's the change in y? The one that goes vertical, and then that's your change in x. So negative 2 over 2, that actually simplifies to negative 1. So the slope of this is negative 1. In fact, I can go down 1, right 1, down 1, right 1, down 1, right 1, and that's my line. Number 3 says use the graph below for questions 3 through 5. Okay, what is the slope of the graph above? Okay, so let's see. Basically, all these little triangles, they're just giving you your arrows, basically. So you can choose. I'll probably go for the smallest triangle because then I don't have to reduce, but I'll show you both ways. So let's say I decide to start here at C and go to E. So you can follow this triangle. I went down 1 and then right 2. So positive 2. So the change in y is negative 1, and the change in x is positive 2, so that comes out to be negative 1/2. So the slope of this line is negative 1/2. Let's say you decide to use this triangle. So you go, or if you want to go left, 1, 2, 3, 4, that's negative 4, and then up 2. Now, change in y over change in x for this one will be positive 2 over negative 4 because this is your change in y because it's vertical movement. And if you reduce this, it becomes 1 over negative 2, which is negative 1/2, which is the same as this. So all of these little triangles is basically to show you that it's going to be proportional. What is the y-intercept of this line? Okay, it is 0, comma 3. Where does the line cross the y-axis? It's at 0, comma 3. Okay, write the equation of the line in the graph. Okay, that's easy enough. Y equals, the slope is negative 1/2. Remember, blank x plus blank. The m goes here and the b goes here, so negative 1/2 x plus 3. And that's your equation. Okay, number 6. Jeremy charges a customer $15 per hour to cut his lawn plus a $10 base rate for travel. Write a linear equation to represent this scenario. So basically it's this. And the $15 per hour goes here, and the plus 10, it goes here because that's your initial value, rate of change. Another way to say it is slope and y-intercept. Number 7. Using the information in question 6, how much would Jeremy charge a customer for 4 hours? Okay, so if it's $15 per hour, then $15 times 4 hours, if you put that in your calculator, that comes out to be $60. But then you must pay the $10 base fee, so that's $70. Okay, another way to look at it is, if you want to write it in the equation, remember y represents the total amount that he would charge. So it's 15 times 70 plus 10. I mean, not 70, sorry. 15 times 4. 4 hours. That's going to be 60, and then plus the 10 is 70. Number 8. The graph below shows the growth of a plant over a series of days. What would the height of the plant be after 50 days? So it looks like the graph, the plant grows 5 inches. Nope. It grows 1 inch every 5 days. Okay? So if you want to think of this as unit rate, there's a couple of ways to think about this. Okay? You can say, well, how many in 10 days, in 15 days, it's 3 inches. Okay, so you can say, well, what will it take for it to be, how many inches will it grow in 50 days? So What did you have to do to get from 5 days to 50 days? You multiply by 10, you multiply by 10, and you get 10 inches. So the answer would be 10 inches. Let's see if that's true, because here it's 1 and then 3. And then here at 30, you have 6 inches. Okay, so yeah, that sounds reasonable. Another way to think about it is, okay, let's think about unit rate. So if the plant grows 1 inch in 5 days, let's see how much it grows in 1 day. So divide by 5, divide by 5. So this becomes 1 day, and then 1 divided by 5 is 0.2. So the plant is growing 0.2 inches per day. So now all you got to do is multiply, okay, the bottom by 50 to get 50 days, and then multiply the top by 50. Okay, and let's see what that comes out to be. So for 50 days, how much does a plant grow? 0.2 times 50, and that's 10 inches. That's another approach. I'm curious to see what other approaches you guys came up with. Okay, let's do number 9. All right, lots of words, but don't let that throw you off. All right, we're going to take this a piece at a time. Cami Cakes in Atlanta is preparing to donate cupcakes to Sweetwater Middle School for an end-of-year celebration for honor roll students. Okay, that's nice, but that's really not giving us any math, right? We're going to go on. Cami Cakes charges a delivery fee, okay, plus the price of the cupcakes. Okay, use the table below to determine the equation that best describes the relationship between the total cost, which is y, yes, whenever you see the total, it means y, and the number of cupcakes, that must be your x, which actually, see right here, there it is. All right, so let's, if they're wanting an equation, this is the way we're going to write it. Okay, write an equation that represents the relationship between the total cost and the number of cupcakes. Okay, so let's, slope goes here, or rate of change, and the initial value goes here. Now initial value, remember, has to start with 0, comma something, so we need to know what the cost is for cupcakes at stage 0. So if you notice here, this is going down by 5, down by 5, down by 5, and if I keep doing that, down by 5 again, then I'll have 0, I'll have stage 0. So I just need to figure out what this will be, what will be the cost. So let's see what's happening here. How did it go from 41 to 33.50? Let's see, I'm going to subtract 41 minus 33.50. So it went down 7.50. Ooh, I don't know what that is. Oh, okay. 7.50. Let's see, if you subtract $33.50, subtract $77.50. Yeah, 7.50, 7.50, and then 7.50. So let's see. If you take $11 and subtract 7.50, you get 3.50. So okay, without it selling any cupcakes, looks like the delivery fee is just $3.50. So that's your initial value. That will go here. We had to figure it out because the table didn't show us what the y value was at 0, so we had to create our own 0 and find our y. And then the rate of change is that every time for every cupcake, okay, and you can do the slope here. Let's say this is x1, y1, x2, y2. So I'm going to do y2 minus y1 over x2 minus x1. And you get, let's see, y2 minus y1. So $41 minus $33.50. And then we've got 25 minus 20. Okay, so let's do 41 minus 33.5, and that's 750. And then 25 minus 20. Oh, that's obviously that is 20 minus is 5. Okay. All right. So now let's divide that. 750, 7.5 divided by 5. It's $1.50. Does that sound right? Yeah, that would be the rate per cupcake. So yes, this is per cupcake. So since this is changing by 750 and this one's changing by 5, we got to take the 750 and divide by 5. That makes sense. Change in y over change in x. So $1.50. Just know you got to do change in y over change in x. Okay. So this was the base cost for the delivery fee plus the price per cupcake. It makes sense. $1.50 per cupcakes is reasonable. Okay, number 10. As a machine salesperson, Isabella earns a base salary plus a commission for every machine she sells. The table representing her salary is on the right. So this is Isabella. Michael, on the other hand, earns a salary that is modeled by the equation S equals 200M plus 40,000. In the equation, S is his total salary in dollars and M is the number of machines sold. Which of the following statements are true? Michael makes $300 more per machine than Isabella. Well, let's see how much he makes per machine. Here is how much he is making per machine. Because this is the slope, this is the rate, and you multiply it by the number of machines plus his salary, that'll give you the total salary that he makes. So that's how much she's making. As Isabella, with every machine, it looks like she's getting $300. Because if you notice here, one machine sold, she gets $40,300. Two machines sold, she gets $40,600. So it looks like you added $300 for each machine sold. If I go down one, let's say I'm going to put the 0 here. Let's say we go down one, then what's happening is that she's going to make $48,000, okay, as her salary, okay, to go up 300. So let's see, Michael, so she's making $300 per machine. All right. So Michael's here, and this is Isabella. And it looks like she's making more. So Michael makes $300 more per machine than Isabella. No, he doesn't. He doesn't even make more. Michael earns $100 less per machine than Isabella. That's actually true because she's making $300, and that's $100 more than that. You can always do $300 minus $200, and that's $100 as well. Isabella earns $100 less per machine. No, because she's already making more, so that's wrong. And Isabella earns $200 more. No, she only makes $100 more per machine. So B is correct. Number 11, what is the equation of the line shown on the right? Remember, we're looking for mx plus b. So let's see. I like to write the b because that's pretty easy to look for. That's where the line crosses the y-axis at positive 2. So I'm going to write plus 2. Let's see, can I eliminate any of these? Yeah, this is plus 0, so it's not that one. It's this one, or that one. Gonna have to look at the slope. Now it's a negative looking slope, so these look good, but that one's positive, so I'm gonna eliminate that. Now it's between these two. Thankfully, they already have triangles drawn for us, so I'm gonna use them. So let's say you want to use this triangle. So I'm going down 1, 2, 3, 4, 5. That's a negative 5 because we went down. Turn the corner 1, 2, 3, 4, 5. All right, which one's your change in y? The one that goes vertical, and then here's your change in x. So change in y over change in x is going to be negative 5 over positive 5. And when you divide that, that becomes negative 1. So which one is negative 1? This one right here. The answer is C. The equation of this line is y equals negative 1x plus 2. Number 12, which of these set of ordered pairs would define a line with a negative slope? Oh, we did this for a warm-up. Okay, be willing to do the work. So some of you might like to do the y2 minus y1. So if you do that, I'll show you this way. Then y2 minus y1 would be 6 minus 7. x2 minus x1 would be 9 minus 5. So that's negative 1 over negative 4, which is a positive. Ooh, man, that's a positive, so I want a negative. It's not that. So, or you can draw. So let's say I'm going to do A. So 5, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, it's about here. And 5, 9 is up here. That's vertical. That's an undefined slope. It can't be negative then. All right, see how quickly I did that? Let's try B. I like the drawing part. Negative 2, negative 4, I'm going to eyeball it. So negative 2, negative 4, it's about here. Negative 1, negative 3 is about here. That's a positive slope, so it's not that. It has to be C, but I'm going to double check. So let's say I have a point at 0, 8, that's up here, somewhere up here. And then negative 3, 4, negative 3. Uh-oh. These are all positive. This is not good. Let's see. Oh, I messed up. Oh, man. Guys, I apologize. I can already tell that this is going to be positive. Negative 3, positive 4 is about here. That's positive. See, that's a good thing I checked all the other answers. Okay, so 6 minus 7 is negative 1. 9 minus 1, 9 minus 5 is a positive 4. I am so sorry about that. So the answer is negative 1/4. This was actually the correct answer. Good thing I checked the others, guys. That's a lesson for you too. So the answer is D.